Hi, today we're going to look at rational exponents. Rational exponent is having an exponent that's a fraction. And you can get that by having something written in either exponential form or radical form. And we're going to learn how to switch back and forth between both of these to make it easier to solve these once we have numbers in there. So rules, let's come up with something. So exponential form to radical form, we need a radical sign. So underneath that radical sign, you're going to have that big X there. Now, the exponent is broken up into a numerator, denominator, top, bottom. Those two numbers are going to go in those same exact spots, just kind of split off a little bit. So 5 is in the bottom of this fraction. It's going to go to the bottom of our problem here in the index. Let's try and write that a little neater. That 2 is up in the air in the top of the fraction. It's going to go up in the air in the radical. And there you go. You just went from exponential form to radical form. Now, can you go the other way from radical to exponential? Sure. You're going to have the y. Now, 4 is on the bottom, 3 is up top, so 3 over 4. There you go. You're done. Just know that this may look a little differently at times. You might see an index of 4y to the exponent of with that 3 on the inside. You may see index of 4 with the y and maybe even a parenthesis exponent of 3. All three of these all mean that same thing. So anyways, we have our rules. We know what to, we now know how to move our problem. So let's look at it with numbers. We know we're going to have a radical. 64 is going to be inside. 3 down, 2 up. 3 down, 2 up. Okay, now we need to go through and ask ourselves, what gets multiplied by itself 3 times to give me 64? 4 times 4 times 4 with an exponent of 2. What got repeated 3 times? Well, 4 got repeated. We did not touch that 2. Bring it over. 4 to the second power gives us 16, and we're done now. All right, next one, 125 to the 4/3 power. So now we have an improper fraction as the exponent. Still follow the same rules, that's fine. Radical 125, bottom 3, top 4. So now I'm asking myself, what gets multiplied 3 times in order to give us 125? In this case, it's going to be 5 times 5 times 5. I'm going to skip this step and just run to here. So we'll say 5, and then to the 4th power. All right, so now you got to figure out 5 times 5 times 5 times 5, which would end up being 625. What if we have a negative exponent? Okay, so let's kind of ignore the negative for a second, and let's just go with our regular system. We know we have an 81 here. We know that 4 is on the bottom, and we know 1 will be up top. When you have a negative exponent, it doesn't matter if it's in the numerator, the denominator, or all the way out in front. As long as there's one negative, it means the whole thing's going to be negative there. Now, for this problem, and you're allowed to shift that negative up and down wherever you want to put it. In this problem, if that negative was down with the 4, I'd have a negative in the index. I don't know what that would mean. So just make sure that that negative stays with the exponent, with that top number. Now, let's ignore this for right now, and let's just do this part here. What gets multiplied by itself 4 times in order to give us 81? Well, in this case, it's going to be 3. Bring that negative 1 over. All right, now we have to go back to our rules of exponents, where if you ever have a negative exponent, we got to get rid of it. So we circle the coefficient and the exponent, and we're going to move them down. So that's going to give us 3 to the 1st power down there. We don't really even need that 1, but we need a placeholder up top. We get that. And to rewrite it one last time, just 1/3. And that is switching back and forth between rational exponents or rational form, nope, radical form and exponential form, and that's rational exponents.